Now that we've had a chance to practice writing the null and alternative hypotheses, I want to give you one word of warning about writing them. And that is that you need to write down or choose your null and alternative hypotheses before you look at your sample data. So writing hypotheses is a lot like calling a coin flip. Once that coin is in the air, you're going to call heads or tails, and they will not uncover that coin until you've made a decision about heads or tails. So the same way, you need to write down your hypotheses before you look at your sample data. Ideally, you would do that before you even collect your data. But in a situation like this where you're in a class that you know that data is already sitting there ready for you to work with. And so you want to not look at that and not make any calculations until you've written those hypotheses down. That way you're not swayed by what you're seeing in the data. So the idea behind a hypothesis test is that we start from the position of assuming the null hypothesis is true, and then we gather evidence or data to see if the null hypothesis is plausible or believable, or if we think that the evidence is strong enough that the null hypothesis is most likely not true. So if we revisit this free throw shooting, remember I said that I was a 75% free throw shooter, and when you challenged me to go out on the court and shoot some free throws, I only made 11 out of 25 of them. The probability that I would only make 44% of those free throws, if I'm claiming I'm a 75% free throw shooter, is 0.00017. So in other words, if you had me go out and shoot 25 free throws every day over and over and over again, only 17 times out of about every 100,000 tries would I make as few as 11 out of 25 if I was really a 75% free throw shooter. That small probability is what convinces you my claim is false and that really I'm less than a 75% free throw shooter. All right, so let's take a look at where we're going to get that probability from. And so we start out by calculating a standardized value like a z-score, except for we're going to call this one a test statistic. And this actually should look really similar to what we did in chapter 3 with z-scores, where we had a sample mean or a data value we were interested in. We subtracted off the population mean. So in this case, that's going to come from our null hypothesis. And then we divided by the standard deviation. Now, if you look at the bottom part of this fraction, what you'll see is that it's really the population standard deviation sigma over that square root of n. And that's that standard deviation from our sampling distribution that we saw in chapter 15. Okay, so those pieces should look really familiar. So once we've calculated that test statistic, we can find the probability remaining in the tail. So that probability beyond the test statistic or beyond our sample mean. So if you remember in chapter 15, we also looked at that example with the frozen soda drinks. And so the null hypothesis in this situation would be that the drinks are full, meaning that the mean is 20 ounces. And I'm claiming for the alternative hypothesis that they're shorting me, so that the mean is less than 20. So if you remember, I calculated a sample mean of 19, and we had a standard deviation of half of an ounce. And so if I calculate that test statistic or z-score, I'll get negative 14.142. So if we think about what that means in terms of a z-score, z-scores are usually between -3 and +3. So a negative 14 is way out there. That's extremely unlikely. And so it shouldn't be any surprise that that probability there is 0. So you're going to be able to use Rossman chance in order to find that probability if you would like. But also I have this set up for you in a spreadsheet. So that same spreadsheet that had our chapter 16 confidence intervals, there's a tab for our hypothesis test. And so again, you're only going to be changing the values in these boxes that are in yellow. So you have x bar, your sample mean, mu, which comes from your null hypothesis, your population standard deviation, and then your sample size. And this will automatically calculate your test statistic for you, as well as that probability. So either that left tail probability, right tail, or two tail. And you just need to take the probability that matches your alternative hypothesis. So if your alternative hypothesis was less than, that's a left tail probability, you would take this 0.035 as your p-value. All right, so we'll get some practice with that in a little bit. But in the meantime, we're going to go ahead and take a break before we go to the next video.